All right, everybody got this down? So a little bit of review of graphing by hand. How do you graph a line by hand? What are strategies you remember from last unit? Three different methods I can think of for graphing a line. Can you tell me one? Can you tell me one of the finding the intercepts, x-intercepts and y-intercepts? Good. That's one way of graphing a line. What are the other two ways of graphing a line? Graphing. Finding the intercepts. In this case, in the first example, if you did that, you would get fractions for both of them. So it's not necessarily always the best method, but it would work. It's another way you could graph a line. You should be able to think of three really quick. Using the slope intercept form. Y equals mx plus b, because then you would have the y-intercept. And once you have a y-intercept, then you could also find out the slope and find another point that way. Good? And the last one that people always forget about, but which is very powerful, is a table of values. All right. So, the most common of these for graphing is probably the second one for graphing lines. Change it to y equals mx plus b. You'll usually have a nice point for your b value and then a slope. However, if your y-intercept isn't a nice one, sometimes a table of values is a very nice one, and then you can use your slope or other points on your table of values to graph it completely. So first thing I'd like you to try to do, give you a couple seconds, is just practice your algebra, change those to y equals mx plus b. How did you do? There they are. Y equals negative 2/3 x plus 1. And y equals x minus 4. How did you get the x minus 4?
Yeah, I got negative x plus 4.
Well, if you move did you move the x over to begin with? If you move the x over to begin with, you would still have negative y.
Oh,
and then you have to divide everything by negative y.
Yeah.
Okay? What I did is, because the y was negative, I moved the y over and then subtracted the 4. That also works. Now that you have both lines, and we're going to use that second method, we're going to graph this one in red, and I'll graph this equation in blue. So if you get it in y equals mx plus b form, it's easy to graph because you have a point to start with. You know the y-intercept. For the red one, our y-intercept is at 1. Then our slope is negative 2/3, which means it's going down from left to right. A rise of 2, a run of 3, down 2, over 3, down 2, over 3, up 2, over 3 this way. And you can draw a bunch of points and draw a line through those points. Some of the points you might have to make look big so the line goes through them. And there's our red line. Our second point, 2 over 3, got another one. There, I have all the dots on there that are possible. The second one was y equals x minus 4. So we're starting with minus 4. With just an x there, the number in front would be a 1, which is 1 over 1, positive slope, over 1, up 1, over 1, up 1, over 1, up 1. And the solution by graphing, when they're asking you to do it by hand, it'll always work out that the point is a nice one. You can see that it worked out perfectly that here at 3, -1, the two graphs intersect. And so this is the solution. That is the only x value and y value that makes both of those equations true. If we go back to check them, if you plug in 3 for x and -1 for y, see that the first equation, 2 times 3 would be 6, plus 3 times -1 would be -3. 6 plus -3 would be 3. The first equation works. The second equation, 3 minus a -1 would be the same as 3 plus 1 equals 4. And that's the only values of x and y that make both of those equations work.